we go. Let me move that. Okay, I think we're live. If you guys can hear me, let me know in the comments. If you can't, I'll adjust. Let's see. Okay, looks like hopefully we're coming through. I think so. Cool. All right. So looks like looks like this sound's coming through. Sweet. Okay. Fantastic. All right. Yeah, we got some more people coming into the chat room. Good, good, good. All right. So, let's see, got a few more people popping in. All right. Well, we'll go get started. So this morning, I thought I'd start with some Wireshark. We've got some questions that came in from last time, and let's see, I think I'll just adjust my screen here. Okay. So I just say good morning to everybody. Everybody say good morning now in the chat I'm seeing. So yeah, once again, we're working with about a 15 to 20 second delay. So if I say something, you'll hear it about 20 seconds later. But for some reason, the chat comes through about 5 seconds later. So I'll see your chat response probably pretty quick, but you'll hear my voice with about a 20-second lag. It's just you have to deal with it with the live stream stuff. But it's good to see everybody again here. Thanks for coming to the course. And what we're going to do is start with some stuff from last week. There were some questions I saw, like as I was killing the live stream, about not being able to see certain things on Wireshark in particular, things that have to do with encrypted, well, I should say voice communications. And so I was just going to kind of give you a little bit of an understanding of what you're seeing there, because I get the question all the time. It's like, hey, we know we've got VoIP systems, or hey, our client is using, Hangouts or chat or a Slack, all kind of things, and we don't see the communication that's occurring, what's going on. So I'll kind of give you a little bit of a quick introduction into what you can expect to see in a normal VoIP type of setup, but what happens when you don't see anything and what's occurring. So I don't have these packets up for you to look at on the website. I just kind of threw this up real quick and just have a quick discussion about it. But what you're seeing on the screen right now is a normal VoIP telephone call, right? So kind of ignore everything from here up, because there's just some weird authentication stuff that's occurring, some option stuff. But really, any VoIP telephone call that involves SIP traffic, and SIP is kind of the setup protocol for the call itself, is going to involve these packets. So you're going to have an invite packet that's kind of a request to set everything up. You're going to get a trying, a ringing, and an okay, and an acknowledgement. So this just kind of bounces back and forth from phone to phone to set up the call. If I go to VoIP calls and look at this thing called a flow sequence, it shows me kind of the direction those packets head. So you get an invite from one phone, you get a trying, a ringing from the other one, you finally get an okay, and then an acknowledgement. And then after that, what happens is you get this flow of traffic. It's RTP traffic, or real-time transfer protocol traffic. What it's doing is, this is where the voice actually is, and so there's tons and tons and tons and tons of these packets. And this is just your typical VoIP setup. Now, in the class that I teach, the basic VoIP, we go into like some really fine detail into what's happening in this invite, what's happening in this header, what can you look at, what can you pick out, what information can you glean from it, because there's a lot of stuff you can find out from a VoIP device and from its communication path. But generally it's all in the clear, right? So you have this setup procedure, then you have all the voice. In fact, you can take this voice, you can go to VoIP calls, you can highlight the stream, you can go play stream, and then you can actually play the voice back, right? So it's very clear, it's very easy to pick out. And generally people, if you're just getting into Wireshark or you just start looking at VoIP, end up sussing out some way. They watch a YouTube video or two, and then they kind of figure out how they can break the audio back and listen to it and all that good stuff. So we're going to look at a different case though. The other case is, I'm going to open this one up. So this is a capture that I have that involves 4 SIP devices. So I'm just going to go straight to the flow sequence here to try to see what's happening. We'll start with one and then we'll look at the other. But we've got some sort of SIP activity between a .17 and a .121. So similar sort of setup. There's some stuff happening before the invite, but mainly you have an invite, you have your trying, your ringing, your okay, your acknowledgement, and then the thing, the voice transmits as you would think. And then if you look at the other one, oh, wrong one, sorry about that. Let's see, you have the same sort of thing. So from 120 to .16, you have another SIP conversation occurring. The thing that's interesting though is that this is all one conversation and it's occurring between 4 devices. So if I highlight both of them and hit flow sequence, you'll see .17, .121, .120, and .16. And it looks like there's no communication in between the two because this whole column is blank. But actually there is. When I recorded this, .17 is a VoIP phone, .16 is a VoIP phone, .121 is a PBX, and .120 is a PBX. What I've set up here is I've got a SIP call that is occurring between .17 and .16, and the phone call goes from 17 to its PBX. This PBX then sets up a SIP trunk that occurs just like a SIP call from 121 to 120, which is the PBX for .16. 120 then reaches out to .16 and completes the call, and then traffic starts to flow between .16 to .17. But you can't see that here. You can't see the full flow because what I did is from .121 to .120, I encrypted it. So this is encrypted using TLS encryption, and at the SIP level, or I should say at the RTP level, it's using SRTP. So there's really, what happens is that call setup, where you have the call setup happening in the SIP protocol, that whole setup is TLS encrypted. So it's, like if you go to Yahoo or Google right now, you're redirected to HTTPS and your traffic is encrypted from your computer to that website. Well, this is kind of the same thing. We've got some certificates set up on 121 and 120. They encrypt all their communications. So when they set up a call between 121 and 120 over a SIP trunk, that is completely encrypted. And so we can kind of see that too. I'll kind of scroll down through the packet capture. You can look close and you'll see the green is the SIP setup. And so we have some setup between 17 and 121. We have some setup between 16 and 120. So, all of this kind of setup occurring, and then we have RTP voice. What you'll notice is that from 121 to 17, you have RTP traffic, so that is clear text audio. So from the PBX to from the PBX to the phone, from the phone to the PBX, and then down here from 120 to 16. So then once again, this is clear text from the PBX to the phone, from the phone to the PBX. But then in between each one, you have this UDP packet that is just going from 121 to 120. It doesn't say it's RTP. And the interesting thing, and I'll show you later how you can tell it's encrypted, but it is encrypted. And if I show you what it looks like, so I'm going to bring up a filter that all it will do is show me. So this filter says if it's a packet that has an IP address of 100.121 or 100.120. So this is show me every packet that's going between the two PBXs. Hit enter. And now what we have is just the communication that happened between those two PBXs. And what you'll see is it starts out with TLS version 1 protocol, some TCP traffic, TLS encryption, some more TLS encryption. So this is that SIP exchange occurring, but all of it is completely encrypted. You're not able to see anything. Because you're not able to see the SIP setup, Wireshark doesn't know how to interpret the RTP that comes after it. Okay, so if I were to take and give you a normal phone call and just strip out the SIP information, and I jumped in the phone call just as the voice was starting up, Wireshark wouldn't be able to say, oh, well, that's all RTP traffic. It would just tag it as UDP. And so that's what's happening here is since the SIP setup is encrypted, it's not that we took it out, it's just that Wireshark can't see in those packets. The UDP packets that follow, it doesn't label them as RTP because it doesn't have the SIP information to understand what those UD packets are supposed to be. So as you flow down through here, the other part about this that's really interesting is the UDP packets themselves. I'm going to jump back over to the normal phone call because some of you might be thinking right now, well, this is great, like that explains some of the stuff I'm seeing, but how do I know when it's encrypted? Do I just look for TLS packets? How do I know when that UDP traffic that's supposed to be RTP is actually encrypted and I wouldn't be able to hear it anyway? So if I go back to the normal VoIP phone call, I'm going to clear my filter here. You have some RTP traffic, and what I want you to do is look at the payload. So the payload here has some, this is the actual bits that is traveling back and forth between the phones. And if I start to scroll down through them, you'll notice that there's a lot of repetition in those bits. The reason is because this is clear text. At the start of the call, there's no audio, and so a lot of those Fs that you see, a lot of those 7s that you see, that's just a blank telephone line with nothing occurring. And usually with a SIP or RTP traffic, this is what you see when a call initiates, is you see a lot of the same. There is not a lot of entropy in that bit stream. There's just a lot of repetition. Now, let's put that up against the encrypted one. So if I go back and invoke my filter again, I come down here to this UDP that I know is RTP just because, you know, I put this thing together. But the other thing is I just see a stream of RTP, and anytime you see a stream of RTP, I'm sorry, a stream of UDP, anytime you see a stream of UDP that is just continuing and continuing and continuing, well, then you can kind of assume like, well, there's some kind of streaming going, whether it's video or audio or whatever. But if I put this on here, and I'm gonna tweak my filter just a little bit more. What I'm gonna do is I pre-prepared a filter that says show me every packet that's going from 121 to 120. So I just want to see a single side of the stream. So everything going from 121 to 120, all I want to do is see that UDP traffic. So if I click on one of these and start going down through it, what I want you to do is look at this part of the bit stream, starting here after this F, all of this, every single packet, I should say starting after the F6 right here, every single packet, the payload changes. Okay, so what this lets me know is that that's a very high degree of entropy, and because of that, what you're seeing is you're seeing evidence that there could be encryption there. The more, a lot of times the way that you figure out if an encryption algorithm is good is measuring the amount of entropy that you're seeing from the output. And in this case, you can kind of see that, wait a second, those packets, they change all the time. Like all of this down here, this payload, is every single packet is wildly different from one to the next. So that lets me know that it's encrypted. So just kind of wanted to point that out this morning because I know I had an email or two and actually some comments and stuff talking about, well, what, I don't see, this particular type of communications every time I look. All I see is I just see packets that don't seem to make sense. So what I would challenge you to do is go back and look at those captures again. Find the device that you're looking for by looking for the source or destination IP address of those packets and filter on that. So if your device is located at 172.16.100.121, go ip.addr equals, throw that device in there, and then scroll down. If you see a lot of UDP packets or something that looks UDP-ish, that is continually pumping out tons of packets in one direction the whole time, well, then that'll let you know that there's some streaming going on. And then maybe what you want to do is look at, okay, was the setup obscured? Was it encrypted? Does it look like the payload for this stream is completely random every single time? If that's the case, then you might have an encrypted stream, and the most you're going to be able to do is kind of see where it's coming from, where it's going to, maybe the MAC address is involved in it, and a little bit of the setup. But yeah, so just wanted to point that out this morning. If you have more questions about Wireshark or things of that nature, let me know. If that was too fast or too confusing, also you can let me know as well. I'll address it in the next live stream or even on this one if we have some time towards the end. So this morning, so let's see, what do we got? We got more people coming in. Good. Ben's here. Israel, Dennis, Ray. All right, cool. Yeah, more people. Excellent. Oh, we're at 55. Huh? Ralph. Oh, Ralph popped in? Oh, sweet. Yeah, oh yeah, there's Ralph. Yeah, we're up to 54, 50, 55 people. Nice. All right. So for what most of you are here for this morning is about host defense. And so I'm going to go ahead and kind of acknowledge that I know that for this particular topic, there is going to be a lot of different levels of understanding here. So I come from a background of having a bit of the defensive side under my belt right now. It's no mystery if you go look at my LinkedIn page or anything else, I'm kind of into red teaming. And so I look at this now from a perspective of how do I attack the box? What are my options when I'm on a box? A lot of my stuff is more from the physical side of things, but I work with and have my hand into some of the networking side of it a bit, like I said, from my past life and some of the stuff I'm doing now. And so that's kind of my perspective. From a red team type of perspective, if you have a company or some enterprise or whatever and you hire a red team, you'll know that most of the time, or actually all the time, if it's a good red team, their primary purpose is defense, right? So they are there to perform a job, to act like the bad guy, to look at your network and to see how they can find an avenue of attack, right? Their main purpose of a red teaming, the difference between a red team and a pen test is that a pen test is there to kind of give you an overall look at your entire network, kind of enumerate vulnerabilities, say, hey, we could have taken advantage of this. A red team is there to really provide effect, right? So if you hire a red team, they're going to take a look at that network, they're going to find a vulnerability, and then they're going to jam a knife in it. They're going to actually exploit it. They're going to show you and provide that effect to you to see what would happen if that person actually took advantage of that vulnerability. They're not there to enumerate all your vulnerabilities. What they're there for is to find that one, avenue in. And in that respect, Some of the commands that I'll show you is something that we look for when you are messing around with somebody else's box, called looking for cohab or cohabitation, right? So in other words, if I'm a red team guy and I jump on your box and I am doing my job to try to make things better for your company by giving you some tips on how you could have kept me from getting on your box, but I get on your box and then I realize that I'm not the only one on the box, okay? So I might have some commands that I have in my hip pocket that I can run to tell, like, am I the only one here? And there's some other commands that I might run to say, like, hey, when I was there, I was taking advantage of this vulnerability, but you might want to take a look at this one over here because I could have taken advantage of this one too. From the defensive side, in stuff that I've used to do, it's purely defensive, right? So you're hired on as kind of a blue team type of aspect, and you are given control of the box or given some sort of account on a box, and then you're given a certain amount of access, and then you go through and consciously run these commands looking for the presence of an individual or malicious actor on that particular box. So it's really a very much in both aspects. Sometimes it's very much a run and gun type scenario. There is, if you are a true blue teamer, in that case, you are giving probably access to a network, right? And you can run these commands remotely. You can run these commands from a different box. You can do all sorts of things, and you have an entire huge arsenal of commands at your disposal, and you'll have a lot more insight. So where this discussion is going to take place is not so far as the true blue teamer who has a lot of access and can overturn every stone, but it's not so much from the aspect of the red teamer who, like, you just jumped on the box, you got a few minutes, you want to make sure there's not another bad guy there, and then you're going to continue on your way. So we're going to be looking at kind of in the middle, right? So let's say you have legitimate access to the box. You have probably a few minutes with each box. Maybe you've got anywhere from 5 to 15, 5 to 20 minutes with the box, and you have a few commands you want to run, right? Like, so this scenario is kind of the scenario you might have, if you were asked to do some preliminary home defense in a small business. It is the same aspect you might have in your mind if you go to your parents' house and they're like, hey, we went to we went to this website so we could download our $1,200 check from the government, and it did some weird stuff to our box, right? So that's kind of the area where we're looking at. I've got a few minutes with the box. What is it that I can find out? If you've got some commands that we don't mention, feel free to throw them in the comments. Brandy's over here kind of taking notes and questions. I got an email for a couple of things, and we'll go over those as well. So thanks for the emails if you sent one. And we'll get started. So if you've got your computer in front of you, which I know you do, because if you're watching this, you probably got something. But we'll kind of step through these, and I'll be referring to some notes here. This is going to be part of an upcoming class, and so this is actually good that we're doing this because it helped me build out some of the material that I needed to. So thanks, guys, for coming to this. So what we're going to do is we're going to get started with normal commands you can run from command line. So if you don't know how to get to the command line, there's a couple ways in Windows you can do it. If you've got a search bar in the bottom left corner, you can just type in CMD and hit enter, and that will bring up command line. Another way you can do it is you can hit your Windows key on your keyboard, hold that down, and then hit the R button, and it'll bring up the run window. This will be handy for later, and that key combination, Windows key R, is very helpful to remember. And then it'll say, it'll have a blank line here. You type in CMD, you hit enter, and once again it gives you a command window that you can type anything in. Reduce my video here, so yeah. So once again, if you didn't see that because my fat head was in the way, it's Windows key R, type in CMD, hit enter, and you get your command line. All right, so I've got my command line up here. I have chosen to go with the color Hacker Green for my font, so add a little pizzazz. The first command that I want to take a look at is a command called system info. So kind of the first one, this is to look at just kind of a holistic view of what is my box. Like, what's the computer name, what's the, what kind of memory do we have in it, what kind of network connections do we have. You'll run it. This along with one other one is probably the command that takes the longest. It takes like 3 or 4 seconds to run. So you hit enter, it pops through it, loads some things, and then you'll notice you have some stuff that loads up. I'm going to start from the bottom just because of how it printed out. So you've got from the bottom here, you've got some network cards, so it lets you know what network interfaces you have. So I run a lot of virtual environments on this machine from time to time, so you'll see a lot of VirtualBox, VMware type stuff. There's a one called Tap Windows. That is not a malicious tap. If you have Wireshark on your box, you'll probably have this interface, this Tap Windows adapter V9. And then at the top, we have my actual NIC, Realtek PCI Gigabit family controller. So it has the IP address I'm running at, my DHCP server, IPv6 information. For you guys who do a lot of heavy defense stuff, the next block is fairly important, hotfixes. So hotfixes lets you know what patches had been installed on this box. So if you find, and I've found them, if you see some box that is some old Windows box that maybe has seen a network once in a blue moon, or it's just found on the network and it wasn't joined to the domain, or just a number of things. What you can do is, when you run system info, it'll tell you, how updated the Microsoft patches are, the hot fixes are. For a bad guy, this is particularly interesting because it lets them know, like, well, oh wait, this thing wasn't up, patched. It stopped being patched up to this point. So that means I can go back and look at the vulnerabilities, and this box will be, vulnerable to certain things that Microsoft have patched since then, right? So the hot fixes block here can be fairly helpful for that. And I'm going to show you another command to get you some more detail with that. Let me see. I'm going to stop scrolling up here because the information above this is inconsequential except for one piece that I don't want to show you. And you can probably look at yours and guess what that is. Product ID. Yeah, probably don't want to show that either. Oh well. No, I just playing. So you got Asus is my manufacturer. You've got where's the Windows directory. You've got memory. You've got a bunch of different information here. Page locate, the page file system, where that is. The actual name of my box, which is sofa. My wife made a comment when we moved to Tampa that she wanted a sofa, and instead I went out and bought a computer, and so she named the computer sofa. So that has the name there. But it gives you just a lot of nice usable information about the box that you're on, right? So just you can run system info and really quick get an idea of, okay, what type of box is this? What kind of updates have been done? What am I dealing with here? See, the next thing that we're going to look at is sort of, in the same line of the hot fixes here. And there's a command that's called WMIC, W-M-I-C. So if you want a really powerful command that has a lot of flexibility, WMIC is one that you need to look up. So if there's any kind of thing you want to take away as some kind of homework, look up WMIC and look up the different types of things you can query with WMIC, and the different things you can do with WMIC. It's a very powerful command. We're going to look at 3 different things here to give us some information, but I would kind of, if you want to write down something to look at later, look at WMIC. So what we're going to do is type WMIC QFE list. All right, so hit enter on that. So this gives us a list of all of those patches, all of those updates that have been done to the computer. You'll have the web address here for that patch. You'll have the name of the computer, description of that patch, the hotfix ID, what it was installed by, and when it was installed, which is also a big thing, right? So the power of using this over system info is this last column where it says installed on, because some of these, like if you're not, elbow deep in, computer defense all the time, you might be like, well, crap, I don't know what KB453, 9571 is. I have no idea like what that even means. Well, if you run QFE list under WMIC, then what you can get is you get when was the last thing installed on this box, like when was the last security update, right? And if this last security update was done in 2018, well, you've got a problem, right? So all it does is kind of gives you that insight of, all right, I don't know what all these patches mean, but I do know when's the last time you actually put anything on this box at all, right? As far as security. So we have a question here. This may be a little off topic, but is it worth disabling IPv6 if it's not actually being used, just looking at it as another attack vector? I would say, so you could, right? So you can go to your adapters on your computer, and you can go to that particular that particular network adapter, and then you could just straight up disable IPv6. Yeah, you totally do that, and you'd kill that stack, right? I mean, if I'm capturing traffic on a network, I'm going to do that for IPv6 and IPv4, and just kill the whole network stack, so I can ensure my computer doesn't reach out over that network while I'm just trying to do a pure capture, right? So yeah, you could just kill a stack. The thing that I would just caution you on is there is some equipment that's running at IPv6 that you may not be aware of. So for instance, if any of you, for instance, I have a network appliance up there that's called Flying Fox that's made by Epic Solutions. If you haven't seen it, a really cool little product. They sent me a demo model, and occasionally I'll have it on the network. And when I first got it, like it was over IPv4, and you do all kind of stuff. And then they did some updating for me. They threw the software on my computer. I actually gave them a kind of a direct link into my computer, so when I was at work, they could do all the updating for me. And then we shut that link down. And then when I took a look and I was trying to figure out how this appliance was working and being able to communicate with my system, because I couldn't see any IPv4 traffic, it was all over IPv6. And so like they for that appliance, they're using IPv6, and they've got it to where when you set it up at the user site, it just works, and it works immediately because everything is just kind of running IPv6 in the background. So so just be aware that if you go shutting down network stacks of communication on a system, be aware that there's not some sort of app or something in the background or something that a network admin has put on the box that's actually using that IPv6. So just be careful when you're doing that. I would not have suspected that, and until I started taking a closer look, and then I was like, oh wait, this is all IPv6. So yeah, so there's shutting it down, disabling it to keep a path out. Yeah, sounds like a neat idea. Just make sure that you don't run into any trouble there, right? Okay, let's see. So good question though. Thanks, Bill. B Will. All right, so we stopped at WMIC QFE list. The next one is another WMIC command, and these next commands I'm going to give you are all, I labeled these under the category of disk or disk information. So the next one is WMIC WMIC, disk drive, list brief. Now you don't have to put brief at the end of it, but I'll just go ahead and show you. If I take brief off and hit enter, you just get a load of junk. My screen isn't really wide enough to accommodate all of the information that's available. So you'll see the headings and all the information. It just is too much. So if you take and you put in the word brief at the end of it, what it'll do is it'll not give you as much information, but make it a lot more readable, right? So what this is showing is that I have 2 physical drives on my machine. I've got 0 and 1. I've got a Toshiba and then a separate model here. How many partitions are on each drive? And because of that, you can also kind of start to infer which one is the bootable drive, right? Because usually it's going to be the drive with the lowest number, but also it's going to be the one probably with the most partitions as well, right? Because a lot of computers that come out now have a backup partition to be able to reload Windows. There's some other things there. And so you kind of get a good idea of how many drives you're looking at. I have been in the field and on particular jobs and found drives that people didn't know about in a machine, right? Like they had a box of 50 machines come in, and they spread them out on their floor wherever they were supposed to be, and then they actually needed 60 machines, and then the other 10 came in later. The first 10 had 1 hard drive, the second 10 for whatever reason had 2 hard drives, and those got spread out, and they just neglected. They just didn't realize like there was a second hard drive the whole time, right? And so you might think like, well, of course you're gonna know how many drives are in a box. Well, not necessarily. Sometimes I can sneak up on you and maybe it's not mounted, maybe it's not visible to the user. So physical inspection of a box will show you that, of course. But if you see 100 boxes that all have 1 drive and then you have a couple that have 2, you kind of question that. So, but this kind of gives you an idea of what kind of drives you have there. The other side of that, though, is you have physical drives, but also these are all mounted logically in different ways, and WMIC can help you out with that too. So if you WMIC logical drive, all one word, logical drive, and once again, I'm sorry, not logical drive, logical disk. So yeah, I was thinking of disk drive, but it's WMIC logical drive list brief. And so this is going to show you those drives where the mapped part of them. So where they're actually, what's been mapped so that your computer can see them. And so you have a C, a D drive, and then an E drive. The drive type, you could reference that. Just look on Google it. These two, number 3, are both hard drives. Number 5 is actually a disk drive. You got your free space. You got size, provider name's not provided in this case, I'm not sure why. And then the volume name if they have one. And a lot of this is seen if you hit on your computer, if you're using a Windows computer, if you hit Windows key E, you can pop up the File Explorer. And a lot of times you'll see those drives actually mounted right on the left-hand side, so C, D, and E. So yeah, usually it's just a repetition of what you'd already see there. Cool. And the last thing I want to mention, I'm gonna show you this, but I probably wouldn't run it on a box. It just depends, right? So for instance, if you don't have admin privileges on a box, you might not be able to run this command, but disk part, D-I-S-K-P-A-R-T, disk part. If you run that, it's gonna pop up a window asking you, hey, do you want to allow this? So if, like I said, if you don't have admin privileges, this probably won't work on your box. And it's going to bring up another window. And this is a little hard for me to see. Hopefully it's not too hard for you guys to see. But it gives me a separate command window. It says disk part. And what you can do there is if you type in list, it'll kind of give you the options that you have to look at. And so if you go list disk, it'll say, okay, we got disk 0 and disk 1. And then there's also where it says partition. But if you type in list partition, it's going to say, hey, you didn't select a drive, so I don't know which one you want me to show, for the partition. So you can type in select, let's say select disk 0. It says disk 0 is now selected, then go list partition. And it'll show you the different partitions on the drive. So, in this case, I looked at a drive that had a lot of different partitions. So I got a recovery, a system, a reserved, a primary. Majority of this drive looks to be, it's labeled as recovery, but that doesn't make much sense. So, looks like I popped an error here. Make sure, hopefully everybody's, okay, looks like we're back up. Looks like there was a lag in the video there for a second, so I'll just start back over here with this. Yeah, so if you go to list partition, it shows you all of those different drives and kind of gives you a descriptor of all those different partitions, and gives you a little bit of descriptor of those partitions. So is it staying up?
It hasn't shown up over here.
Okay, fantastic. All right, great.
We're about a minute behind.
All right, sweet. So that's disk part. If you want to get out of this, you just type exit, and it'll pop you right out of the little window there. So that's all of the disk commands I wanted to show you. The next thing is more network related. So of the people who did write in, a lot of people mentioned two commands a good bit. That's ipconfig and netstat. ipconfig, just about everybody uses, right? So we'll take a look at that. So it's ip.cinfig, ipconfig, and if you hit enter, it will show you, and I'm going to open this up a little bit more. It'll show you all the network devices that you've got on your box, right? So you got your IP address, you've got your subnet mask, your default gateway, any IPv6 information, and it also has all your other Ethernet adapters here. Like for instance, like I said, I'm running a lot of VM stuff, virtual machines, so there's network adapters associated with that. But this is great, but it doesn't show you the whole story. And most of you know, if you're using ipconfig, use a modifier at the end, use /all. I believe they call that one the /. I always get it confused. But ipconfig /all, and now you get a ton of information, right? So here we are. So now it gives you your host name, which is the name of my computer. It shows you, here's my normal network adapter. Once again, it gives me an IP address, but also gives me when I obtain my DHCP lease, gives me the gateway information, gives me my DNS server, gives me just a whole host of information, my MAC address. So a lot of really good information here as far as my network adapter. Also shows some once again, a lot more information about my virtual box, my VMs. So if you're going to use ipconfig, I'd recommend using ipconfig /all, because that really gives you kind of the full story. The other one is netstat, and a lot of people use netstat. And if you click it, what will happen, or press enter, just type netstat and press enter, you'll see it'll start to kind of, click through the different network connections that you have. So that's what netstat's used for. Netstat is used for showing you the network information that you have, or I should say this, network is used to show you network connections. So what's connected to you and what are you connected to? And if you just type netstat and hit enter, what's going to happen is every foreign address that's out there that can be resolved to an actual DNS type address. So if you went to Google, it's going to try to resolve that IP address to an actual web address. So it takes forever, as you can see. It just keeps kind of clicking along. So you can hit Control-C and end it if it's taking too long. And you can type in netstat tac or -n. So what this does is it says, hey, NetStat, show me, don't resolve all these IP addresses, just show me the numbers. So -n means numbers, right? So if I hit that, now what it does is it shows me all these TCP connections that it does not go out and try to resolve, like say, this particular IP address equals Google, so I'm going to put Google. It just shows me the straight IP number instead, and it runs a lot faster. Another thing that you can do is, as you see, all it showed me is TCP connections. So let's say though, if there's a UDP connection that's there that I want to see as well. So another thing you can do is use -A, and then use -A, and you can combine that with N. So it would be netstat -an. So now, if I do it, it gives me a big long list, and it gives me all my UDP or potential UDP connections and all my TCP connections to include any loopback addresses, any broadcast, any like just pretty much anything, right? And so yeah, it gives me every single connection out there, even though sometimes it might not be useful. Sometimes you might want to just look at TCP. You're getting everything if you use TAC A and N. So a lot of times that's where people stop and they go, okay, well, netstat -an, like that's all I really need. I would contend there's one more flag that you want to put on there, and that's netstat -an, and then put an O, not 0, but O. Hit enter, and it gives you another column, and that column is the PID. And so what this is the program identification number, or the program identification that is running that particular network connection, right? So if I want to know, this particular network connection right here, this, 172.16.0.2 that's going out to this 142, and I want to find the program that's running it, then I need to look for the program that has the PID of 8,364. If I can find that that program, then I know what opened that network connection, because that's kind of what I really want to know from this, right? Yeah, it's important to know that there's a connection going out, but then my next question should be, what program is making this thing do this, right? So I can figure out, right? Because if it's a bad guy, it's a malicious actor that's opened up one of these holes, then what program did he use to do that? So that kind of there is one more thing that you can put on the netstat as far as another flag. If you get -ANO, let's say you only want to look at TCP connections, you can put P, and then, which stands for protocol, and then put TCP after it, and it will show you just the TCP connections. Or you can use UDP, right, and do it as well. So Pat, let's see, we've got recommend the pipe to more. Yeah, so we can do that. So we can take and so what Pat is saying there, thanks for bringing this up, is you've got a, let's see, so let's say netstat ANO. I run this, and there's this big long, list, and now I have to scroll back up to see, what actually came through the screen. What you can do is put the command and then pipe, which is, if you look at right above, kind of at the top of your keyboard, right by the delete key, you hit shift and slash. It gives you this up and down character, this it looks like a pipe. It's just a straight up and down, and then type more after it. What this will do is it'll just make it to where it'll take it one screen at a time, right? And at the bottom of your screen here, you'll see where it says more, and you can keep hitting enter and start going down a little bit at a time to see the output. And I believe, if I'm not mistaken. No, I'm thinking something else. Never mind. But yeah, so you can pipe it to more, and then kind of take your time through the output and not have to just scroll back up, right? So yeah, so thank you, P. Shea, for reminding me of that. So another thing, just with netstat, like I said, you can use P and type TCP. You can also do UDP, right? And it'll show you just the UDP connections as well. So you've got some options there with netstat. I would recommend, like I said, keeping that O on the end of it, regardless of how you use it. And the reason is because of the next command. The next command is called task list. And we will pipe this to more, just because make it a little bit slower here. So we can take that that PID that we've got from netstat, and if there's something we have a question about, we can take the output of task list, and you'll see this happens to be, arranged by the PID, and you can see all these programs and what their PIDs are. You can see if they have a particular session number, the amount of memory that's being used, and so it gives you a good amount of information. But the other thing you can do with task list that you want to do as well is give it a /v, so make it very verbose. So you hit it now, and you get a good bit more information. So at this point, we can tell CPU time, so how long has this thing been running? And we've, if it has a window title, we'll have that, right? So I've got some things here: Windows push notification, NVIDIA, Cortana. So I've got a little bit of a description if I'm trying to figure it out. Calculator, and why calculator's running, I have to figure out. Probably this is great that I'm doing this, because I'm probably going to expose all of my how badly my box is probably ripped to shreds, because this is quite old and I'm probably not doing as much as I should be. But anyway, there's a lot of information here under task list to let you know what's running in the background, right? Like what is up and going. And because of netstat, you'd be able to tie in the program that's actually opening up network connections and why it's doing that. And we can do that real quick. If I do netstat tac ANO, let's pick one out here. Let's say 8364. Run task list. And look for the PID of 8364. Oh man, this is going to be hard because I didn't sort on it. Let's see what we got here. 8364, Google Drive. There we go. Yep. So yeah, that is a legitimate thing running on my box, right? It's Google Drive. So yeah, so it just kind of allows you to be able to pick out, what's going on. And can hit Q to quit. So, oh, that must have been for more. Yeah, so if you pipe something to more, yeah, you can hit the Q button to quit. I hit Control C, but yeah, you can definitely, when you're under more, hit Q and it'll pop you out of it. So thank you, BMW, and I'm sure I wrecked that name, whatever it is. Excellent. Continuing down kind of the network path, ARP, if you type in ARP-A, what it'll do is kind of give you it will give you your kind of your network neighborhood, right? So what ARP is a protocol that's run in order for computers to find out who has what IP address is tied to what MAC address, right? And so when you run this command, it shows you the ARP table for the computer. And right now, if I look at my interface here, 172.16.0.2, it shows me all of these IP addresses that are operating within my network. So I got a .1, I got a 247, 255, 255. That is not a network device. That would be your broadcast. Or multicast, or no, broadcast, sorry. But yeah, so there's a lot of stuff here that doesn't mean much, because it's just, like I said, kind of, addresses that are internal, or like this is for my VMs up here. But it will show you a few things that are on your network, especially. So whatever your computer has been talking with on your local network, that resolution of what MAC address has been talking, what MAC address belongs to what IP address for what it's been talking to will be there. So you can kind of get an idea of, all right, well, why has this computer been talking directly to another computer on my corporate network? So the way the thought of that is, on a really good designed corporate enterprise level network, host machines shouldn't be talking to each other, right? So they should be talking, host machines always talk to servers, servers talk back to host machines. Host machines don't generally, you don't want host machines to talk to other host machines directly. They go through a server to do that, if they do that at all. If that's occurring, this would be kind of an interesting thing to see, like, oh, okay, well, why is that happening? In fact, I've known some sysadmins who've actually set up every device on their network on an entirely different VLAN. And if you don't know what VLANs are, they're kind of like logical segmentations, pretty much enforcing the rule heavy-handedly that a particular host machine is not going to talk to another host machine, right? But with this kind of ARP TAC A, it'll let you know, like, what is your box talking to, like, on the local network. Let's see, net share. Another thing to look at is, if you type in net space share, is what are your shares on the box? So what are you sharing out? So right now, if you look at anything that's $, like $, $, IPC, print dollar, those are all hidden shares that are accessible with administrative privileges. So if you wanted to remote into the box, like, you kind of have to have some admin credentials to be able to make that happen. But the ones with, and these are, they'll be common throughout most of the boxes that you see, right? So if you run this on your box, you run this on a network box, on an enterprise level, like whatever, there's always going to be these hidden shares. Now, whether or not you'll be able to access them, that's a completely different story, because a lot of times you're not going to. But my other one here, I got one called PyShare, and I've got one called VoIP, and I've got one called VoIP TSEM. So those have all been shared, and they still are shared. And so if you're looking at a box, it'd be interesting to see what is it that's being shared to the rest of the world, right? Like I said before, like, usually on a corporate level, the host-to-host thing isn't something that you really probably want to let happen sometimes. But who knows what's going on your particular network. But you want to be aware of what is your computer letting out. Like, if I drop files in this folder, maybe I forgot about that folder and I shared it for a moment so my buddy could pull information off of it. Well, now, like, that time is completely gone. And that's the case in this case. When I was getting ready for this class, I realized, like, oh, I didn't realize I still had those shared out. I didn't go back and correct it because I wanted to be able to show you. And so now I've got, these last two were things that I had shared just to be able to update some class information on some laptops that I had on the network. I never shut those off. And so if you run this command, then you can figure out, like, oh, well, I need to run those off. Also, if you have any kind of network shares or anything that you might have access to, I'm pretty sure you'd see these here. Cool. So that's net share. The last thing that I wanted to look at in the command part here, and we're about to go into PowerShell, which is a little different, is one called Query User. And try running it on your box, and I would be interested to see in the comments how many people actually get it to run. So if I hit it, it's not going to do anything. If I were giving this presentation on a laptop that I have here, it would work and it would give me that information. But what this is going to do, and like I said, if you can run it, let me know that you can run it over here in the comments. Or I guess over there in the comments. I don't know which direction I need to point. But it seems to be, I asked a few of my friends, like, hey, why isn't this working on mine? I think it's because I'm using Windows Home Edition. Also, I'm not joined to a domain, but I believe if you've got Windows Pro, this command should work, and it will tell you what command, or it'll tell you what users are logged into your box at the time. So if you can run it, you will get some information back saying, yeah. So Ryan Wallace looks like, yeah, we got a can run. All right. So yeah. So some people can run it, and it should just show you like you logged into your box. So if it shows more than just you logged into your box and you're unaware of that, you might want to get off this live stream and take a look at that. So Bill Young says nope. So yeah, you're probably stuck in the same kind of thing that I'm stuck in at this point with being Windows Home. But generally, if you have I think Windows Professional, and Ryan, if you have Windows Professional, that probably is the reason why you can run it. Or you're actually joined to a domain of some sort, you can probably run it. But yeah, just as normal Windows Home standalone computer, probably not going to be able to do that. But I would add it to your list if you can. At the worst, what it's going to do is give you like, hey, I couldn't run this command. Okay, yeah. So, all right, cool. So yeah, we got P. Shea says works on my Windows Pro and a VM. Sweet. Yep. Israel can run. Douglas Bonner can run. Yeah. All right. So we do have some people out there who are actually being able to kick it off. So cool. Excellent. But yeah, so obviously a powerful little tool, because it's going to let you know, hey, well, what better to see if there's any cohabitation, right? You run query user and it's you and somebody else that's probably the client, and then a third person too. Like, oh wow. Let's see, not working on Win 10 Home. Yep. So just what I thought there. Yeah. So yeah. So you can see, like, you know, it will work on some, won't work on other, but still a good command to use. So with these commands, I do want to say one thing before we get too much further. We're about to go into PowerShell. That there are times I should say this, if you're running these commands on the box that's under scrutiny, there is the chance that those tools on that box could be compromised, right? So it used to be, and I've done this before, you could take netstat and let's say I had a malicious network socket or something opened up on the computer. I could run netstat, and what I've done before is just write a simple C script where I compiled it, I named that script netstat, I moved netstat somewhere else. My script would then be put into the Windows System32 folder. I would take, run, if you typed in netstat, it would run mine, it would call the real netstat, and then it would take and pull, and get it straight, it would then pull out or discard the malicious network connection, and you wouldn't see it. The output that you would see would just be output minus the network connection that was actually malicious. And so you can, there remains the possibility that these tools could be compromised on the box under scrutiny. So some people like to bring their own tools on a USB drive or on a CD, and bring their own DLLs to back up these commands. I will say that screwing with these files has gotten a lot harder. So I tried the trick that I used to be able to do on modern Windows boxes, and from 2018 that's been tough, because there was a file, it's called Windows, trying to remember what it's called, Windows File Protection, which is no longer a thing. I think now it's Windows Resource, I believe, Protection. But there's and it's also, I think it's run through Windows Defender. By the way, if you're not using Windows Defender on your box, Windows Defender is amazing. Defender will take, and it will, if you try right now to go to, say, netstat and just throw it in a text editor, try to delete out some of the, I wouldn't do this, but I did it. But if you go into netstat, just bring up the hex, delete out some of the hex, try to save it, Windows won't let you do it. I tried all kind of different ways. I tried to do it administratively. It is really hard and fast on keeping file integrity of some of these tools and some of these files in System 32. So what I'm saying is the tools could be compromised. However, it has been a bear to do that. It's getting fairly difficult to mess with it. And if you have Defender running, it gets really hard. Now the thing is, the bad guy, what he could do is he could just turn Defender off if he gets access to your box, right? And then do the thing and then come back. So like, you know, there's multiple systems on enterprise level boxes that you need to have in place, right? So if you've got network defense stuff up, you got Windows Defender, you've got a ton of things that are running to try to watch for this, the harder it gets for somebody trying to mess with it. But just kind of a note on that before I move forward. We got a question over here. Is net user provide same info as query user? I don't think it does. Because net user, and I don't know why I don't have this on my list. Probably should be on the list. So thanks for bringing that up. So net user shows you all of the accounts that are on the box. So administrator, Jason, of course, which is mine, a default account. This one called WDAG utility. So this is actually something, an account for Windows Defender to be able to run stuff in a sandbox, and then a guest account. These are, I think most of these are deactivated, and I'll show you a PowerShell command that'll bring this up and show you some more information. I think that's why I didn't put it on there, is because the PowerShell command gives you more info. But yeah, so net user generally shows you what's available for your what's available on your box as far as accounts that can be logged into. Query user, I believe, shows you currently logged in users. And the thing is you guys can correct me maybe, but I don't know if net user has a flag to be able to show you currently who's logged into your box. I might be wrong about that, but maybe if somebody else there knows, you can throw it in the comments and we'll look at it. But net user also has some other powerful things that you can be able to do, like if I remember correctly, you can reset some passwords, and I'm not, shamefully so, not up on my net commands as I should be. So the other thing but yeah, thanks for bringing that up, LB. Let's see, not working. It says error between keyboard and chair. Great. The next thing I want to look at is something called PowerShell. So you can get to PowerShell two ways. You can either type in PowerShell here in the command line, I'm just going to do this just to show you kind of a difference in screen. You can type PowerShell in the search bar, or you can just hit Windows key R and hit PowerShell. If you type PowerShell in the command window, then what it's going to do is just reportion this. So you'll just get a different prompt. So it says PS in front of it to let you know you're in PowerShell. You can type exit and pop right back out of it. I'm going to do some of my commands over here just so you can see a difference in Windows. Drag this out. So PowerShell is a very Linuxy sort of command line for Windows. So if I type in ls instead of dir, so usually in Windows you type dir, it gives you the directories. If I come over here back to my command window, I type dir, it shows me the directories. If I type ls, it does not. ls is a Linux command. I type ls, it shows me the folders and stuff that are there. So there is a difference in the two different windows, but PowerShell is a pretty powerful, well, as it says, shell that allows you to run a bunch of very powerful commands to give you information about the box, or to give you information about the network. It is for a long time for people doing malicious things to boxes, and still PowerShell was a very nice thing to have around on a box. And so for some of you, you're not going to be able to get to PowerShell because your sysadmins have locked it down and off. A lot of you, though, still will be able to use PowerShell because your sysadmins use PowerShell to administer the box. At the very least, your sysadmins will probably have PowerShell flagged so that if anyone runs anything that's PowerShell related, that they will know about it. So I've got a list of about 4 or 5, about 6 commands here that we're going to go over. Before I do that, though, we have hit an hour and 10 minutes, so I'm going to say let's take a 5-minute break, bio break, whatever you need, and I will be back up and streaming, sitting back in this chair at 11:15. So we'll do that now.
You've just now.
Okay, there we go. All right. Oh, I'm on now. Okay. Let's see. I think we're back. I think just give me a good on the audio there in the comments if you hear me. I'm gonna go ahead and get started, and if I see something different, like hey stop, you don't have any audio, I'll correct it. All right, cool. What we're going to do is look at some of these PowerShell commands that you can run. There is a few of these just do stuff that we've already talked about, and I'll maybe for whatever reason PowerShell is preferred for you. I'll show you those commands anyway. Two of them do stuff that you haven't seen yet. There's one in particular I'm going to show you right away that I'm really kind of excited about. I like it, and just found it this week actually. So in PowerShell, oh good, got good audio, sweet, excellent, thanks guys. So if I go get PNP device, so the command is get -PNP device, hit enter, and it's going to show me a bunch of stuff, but we'll go over it. What we have is, oh, Roger, here we go. Late to the party, glad you got. Good to see you, Roger. So in PowerShell, if you type get PNP device, it'll show you a few things here. This is all of the plug-and-play devices that have ever gone in that computer and are presently still there. So everything it has shown, and oh, looks like my connection dropped for a second. Weird. Okay, I think we're having a little bit of issues. Hopefully this works itself out. Okay, there we go. All right, so anyway, so yeah, we type get-PNP device, and this shows you every plug-and-play device that has been on your computer or still is on your computer. And it shows you, in just by default, status, the class of the device, a friendly name for it, and the instance ID. And that instance ID will have the PID and the VID of your devices. But this is pretty helpful, but you can make it even more helpful. So one of the ways you can do that is hit get PNP device, pipe, and what we're going to do is pipe this to a command called select, and then we're going to tell get PNP device all the information we want to know about the different plug-and-play devices. So the first thing is the captions. You can type in caption, and that's just like a quick name for it. Manufacturer, so there we go. Description, believe I spelled that right, hopefully. Name, and two more, present, and device ID. So some of these are pretty self-explanatory. Like I said, caption is just a short name, manufacturer, description. Because you put caption, you don't have to put name. You could take that out if you want to. I probably would take that out because it's just more information. Present, that tells you whether or not the actual device is still plugged in the box or not. So if you've had somebody that has plugged in, say, an Apple iPad or something, or let's say a phone, to the box, and then the phone has left, then you will be able to see, the PID and VID of the device, what type of device it was, and it'll say false underneath present instead of true, and then the device ID. So if we run this, it will package it a little bit differently, and instead of having it as a table, it's going to show it after you exceed a certain amount of characteristics that you want to know about the plug-and-play devices. It starts to put it in this form instead of in a table, because the table would be way too big, right? So I'm going to scroll back up here to the top because there's one I want to particularly show you, right? So here we go. So Apple iPad, I do not and have not had an Apple iPad on this computer for probably a year. And it tells me, okay, you had an Apple iPad, the manufacturer was Apple, the description was iPad, the name was iPad. Is it still here? Nope, it's not. And here is the PID and VID. So The PID and the VID is the vendor ID and the product ID of that device. And if you go, there is a, I didn't plan on this, but I'll just pop it over here. There's a website, and I want to, yeah, here it is. A website called, it's Linux tacusb.org/usb.ids. And this is a list of a ton of PID and VIDs that exist in the world. So if for whatever reason it doesn't give you a manufacturer or anything like that, or you know, you can actually go to look at the PID and VID to see what it is. So for instance, if you have a, you know, vendor ID of 0001, that's Fry's Electronics, and under Fry's Electronics, if your product ID is 7778, then that's a counterfeit flash drive from Kingston. Sad. But for instance, you can look for Dell. You can look, like, here's for HP. HP is 03F0. We can take a look at F. Let's see, Apple. And this says if Apple is 05AC. So if I bring up PowerShell, I can see 05AC. And it says 12AB. I don't know if they've updated this list, but let's see, 12AB, 12A. So it's not, well, maybe it's here. Take a look. 12A1, 12AB. Here we go. iPad 4 Mini 1. So that was the device that was plugged into the computer. So yeah, really powerful command. Is there a date parameter? That is a good question, Bill. Let me see. Get PNP device. I would need to look up, so this is where we go into the Google things. So if we go get PNP device and go to Microsoft Docs, and we can look and see what kind of parameters that we can have here. So sjob, class, friendly name, instant, present only, status, throttle. I don't know if there is. If anyone out there does know, or knows a place to look at the date, throw it in the comments. I'm not aware of a date part for it, but yeah, all I know is if it's there or not. I'm not sure about if it actually keeps up with the date. But good question, Bill. So yeah, so very powerful command. Like I said, it's probably one of my new favorites there. The next thing works a lot like task list. It's git process, and hit that, and once again, same sort of thing. You get the processes that are running, the ID for those processes, you know, CPU cycles, stuff that are dedicated to that. Actually, this is the amount of processor time, and then you have all of these other columns. And so handles is the number of handles the process has opened. NPMK, so everything that's in a bracket here is a unit of measurement. So NPM is the amount of non-paged memory that's being used in kilobytes. This is the PM is the amount of page memory in kilobytes. WS is the working set of memory. So that's in kilobytes as well. And so it just kind of gives you some memory information. So the only thing that the git process is kind of giving you more so than task list is it kind of gives you resource allocation, right, as far as memory goes. Other one, git network TCP connection. Type that in, and this is like netstat for PowerShell. So it'll show you just the same stuff you get for netstat, right? You get a local address. In netstat, it's called foreign address, but a remote address, the port for each one of them, and the process in a column here called applied setting. which I'm not sure what it does. But essentially it's netstat and PowerShell. And it looks for TCP connections. If you want to use UDP connections, it's get. So that was, in case you missed it and I went too fast, that was get net TCP connection. So get dash net TCP connection. If you want to look at UDP, is get net UDP endpoint. So get net UDP endpoint. And it's the same thing as netstat, except it's going to show you just the UDP part of netstat. So that was get dash net UDP endpoint. If you need something that's like an ARP table, you can get dash net neighbor. So get dash net neighbor. And that's just like ARP dash A. It's going to show you just kind of what's in your network neighborhood, your just kind of the other IP addresses it knows about and the MAC address that's associated with those IP addresses. So, you know, the ones that are really helpful are the ones down at the bottom here. It's 247 and 1, which seems to be the only two. It's only communicated with those two IP addresses. Let's see. Get PNP device property may help Bill. Yeah, so there is another. I didn't look into it as close, but there is another good one there, Ryan. There's another command out there called get PNP device property. I have not looked into that as much, but that might hold the key to the information you're trying to find about the date their bill. Let's see. And so this is the last one I think that is a good command to run. That why I didn't show you net user earlier, or why I kind of left it out, because this PowerShell command get local user. And so what this tells you is it shows you every user on the box, but it also shows you whether or not that user account is enabled. So you can see admin false, default account false, guest false, right? So at the moment, the only thing that's actually enabled on this box, the only account that's up is mine, right? So Jason, it's the only account that's actually running. So that's get dash local user, and it gives you that information. So cool. So that is sort of the deal with PowerShell. And I would encourage you to continue to look at PowerShell. It is just a Swiss Army knife of commands and tools that are endless. I mean, I've got friends that use this thing, like use PowerShell all the time. They love PowerShell. It's just a really big help, and there's just some real power, like is in the name, that you can use PowerShell for. There's a couple things I wanted to talk about before we get into kind of automating some of this stuff. And that one of those things is to talk about environment variables. So there are certain variables that are inherent in the system that will allow you to shorten things, shall we say. So for instance, if you bring up a command window and you type in echo, and you type in anything, so like echo hello, and hit enter, what it does is it shoots it right back at you and says hello. So if you say echo, anything I type, it's going to push back anything I type, right? Even with the quote marks on it. Interesting though, if you type in echo and then you put %, %, it pushes back Windows NT, so it gives me my operating system type. If I type in echo %, random, and end with a %, so %, random, % after echo, it gives me back a random number, and I can keep doing that, and it gives me a random number every time. If I do time, right, %, time, %, gives me back the time, right? Like down to the second, or actually it looks like a millisecond. So there's a lot of these environment variables that you can use to kind of find out like what the time is. But one of the things I'm going to show you is an environment variable called user profile that we'll use later. So it's percent user profile percent. And what this does is it shows you the directory of, so if let's say you log in as any user, it doesn't matter what that user is, even if it's admin, you type in echo user profile, it's going to show you the directory for that particular user, right? So the home directory, which is going to be helpful for us later, and I'll show you how that works. There's also another one that I believe we're going to use, and I need to bring up my little notes here that I have about this. We'll get this in a second. Another one besides user profile that you might want to write down for now is computer name. So it's echo percent computer name percent, and that's going to give you the computer name that you're in. Now for PowerShell, there's a different way of doing it. Instead of putting the percent signs on both sides of it, I'm just going to show you one environment variable. What you do is you put $env, so $env colon, and then you can type, so that means, hey, whatever's past this colon is an environment variable, right? Computer name. Let's see if we can echo it. Yeah, so there we go. So we can echo that environment variable, and it gives us back our computer name. So how is this helpful? Well, it's helpful in a couple ways, right? So one of the things you can do if you want to start automating, or let's just say not even automate, let's say you just want to keep some of the output that you've run. So you've done some, let's say you've run a netstat command, you found some stuff that was helpful, and you're like, oh, gotta spell netstat right. You find some information that's helpful and you're like, I want to put this in a file, right? So what I'm going to do is I'm going to say netstat, tag A and O, and then what you can do, if you can either use what I call a caret, or not caret, so it's the right, I guess, triangle bracket. If you, what this will do is it will push the output to a file. If you use one bracket, it'll rewrite the file every time. So if you run this command over and over again, it'll rewrite the new output of the command to the file and completely rewrite the file. If you use two of them, it will append the output. So you'll run the command, it'll put it in a file, and then you'll run that command again, and it'll go down to the bottom of the file and write the output again. So you have two segments of output. And every time you use the double right triangle bracket, it will continue to append onto that file and make it longer and longer. So it doesn't matter, but however you want to do it, I'm going to use the double. And then we're going to say, all right, I want to push this to C, users, JSON, to the desktop of JSON, and I want to call the file test.txt. Right, so you can do the same thing. You can write it to wherever you want to. So if you want to write it straight to the C drive, or you want to write it, I'd probably just write it in your user directory or write it to the desktop. What you would do is you could do C users and then put your username for your computer here, and or just start typing it and then press tab. And if you press tab, then it will autocomplete for you. And then type /desktop and then the name of the file that you would want it to go to. So Shay is saying it's called redirect from standard IO, and yes, and that's what we're doing. Redirecting this from the standard output, which would be the screen, we're redirecting it to a file, right? So thank you, Mr. Shay. So if I hit enter, it's going to create a file, and it created the file on my desktop up here on the left-hand side. And I need to shorten my command window because I'm starting to block my own image of my comment screen. And I can double click on this and it will show me the output of that file. So this is fine. It gives us a way to drive any command to a particular file that way. But one thing, if I'm having this, if I find a way to automate this, and I'm logging on, say, as a different user on every system, or let's say you have the right to just walk up behind a user and say, hey, I need to run some commands on your box, right? Then, you know, like storing that and trying to be like, well, what's the user that I'm at? Like, well, or what user account am I using right now? What you can do is you can put the environment variable here. So you can say, instead of going C users and then the user username, you can go percent user profile percent desktop, okay? And then your test file. So now what's going to happen if I hit enter is it will write this file again, and this time it write it as a TXT. I'm going to run that again here. So there. So what it's going to do is the user profile, all that is that's now going to be C. User profile is the same thing as writing C user and then the name of the user. But like I said, if you're using multiple user accounts or you're jumping from user to user, you might not have the you might not know what user you are, right? So this will allow you to just using the user profile environment variable, it'll just fill that information in for you. See, if Jason and Doug are on the same box as Doug, can I save to Jason? If Jason and Doug are on the same box as Doug, can I save to Jason? So it depends on, so the question is, yeah, if Jason and Doug are on the same box as Doug, can I save to Jason? You can usually save to the account that you are logged in as, or to the accounts that you have credentialed access to, right? So if you don't have a right to write, if you don't have the permissions to write to Doug's stuff, then you're not going to be able to do that. So there are permissions that are local on the box, but even if both users are on the box, right? If, say, I'm logged on a box and Doug's on that same box, I usually can't write to Doug's folder. The permissions just aren't there for that. If I have elevated privileges, like admin privileges or system privileges, then I probably can. But usually that's something you can do. But yeah, so if I'm logged into my box and I put in user profile, desktop, or if I'm logged in under whatever user I'm logged in on, it'll just fill in that C C:/C user. I'm sorry, C:/users, and then the username for me by putting user profile as the variable. I hit it, it makes my file again, and there it is. Now the other thing that I might want to do is I really don't want to save the output. Like, I don't want to have to write a new name for the output every time. So maybe I want to store all the output under, say, the computer's name, right? So if I put percent computer name, percent, hit enter, what it's going to do is it will now, you can see it just saved the file as sofa.txt, so the name of my computer. Now your name on an enterprise network are probably going to be these big long names that may not make sense, and so it might be helpful, like if you're running multiple commands, you can just keep appending, right, to the computer name. So let's say my next one is, and I'm going to take and copy this, so Control C. So now let's say I do system info. Yeah, just tried that on mine to another user and said access denied. Yeah, and so yeah, that's what I'd expect. But yeah, so let's try, if I try to write another command, so system info, and I append that to the same thing, user profile, computer name. I click that, get it running, open back up. Oh, I think I had Sofa open the whole time. No, I didn't. Okay, go back into Sofa, and now I've got my netstat and my system information all in one file. And so it'll just keep writing to that computer name. So, you know, I can continue to, you know, build this file. And then when I take this file off the machine, however I decide to do that, whether that's email it or whether that's you've got the ability to burn to a CD or whatever, now what I end up with is I end up with a bunch of files, end up with a bunch of files that will all have different computer names and the information from each one of those computers, right? So just kind of an interesting way to use environment variables and redirecting this output to a file to be able to keep up with things. There is something that I do want to point out though. If you write a file, so you're going to have to be careful, because if you redirect from WMIC or PowerShell, WMIC and PowerShell do not output an ASCII format. And so what I mean by that is, let's say I run one of our WMIC commands, right? So WMIC QFE list, and then I output that to and append it to the file we already got going. Hit enter, go in here, I'm going to scroll down. You'll see the output looks really weird. It has a space in between each character. Makes it really difficult to read. And that's because I now have two different file encoding formats in this text file. I have ASCII, and I think the other one is it UTF-8? But it's another output. If I run a PowerShell command, it would be the same thing. However, here's the weird part. If I get rid of this, get rid of the file, I run that WMIC command again, and that WMIC command is the only thing in the file, then the text file will write it in that format and will display it correctly. So what happens is, if you have different formats, you have ASCII and you have, I believe, UTF-8 or UTF-16 in the same file, one or the other one will not be written correctly. So now if I go back, so that file now is set for what I believe something other than ASCII. If I go back and run system info and append that to it, since it's not set to ASCII, now we get a bunch of strange Chinese characters and text and all that kind of stuff, and people start to freak out and, oh, my box is hacked because it's Mandarin. So no, the problem is this down here tried to display as ASCII, this up here was not. So what you can do to get around that is, for WMIC, you have to do it this way, and I believe Mr. Shea is going to love this. If you start off, so I'm going to delete this file. Always start off with at least one command that is ASCII, right? So that's anything that's not WMIC or PowerShell. Run it first. So system info is a good way to do it. So we're going to run system info first. Store it to a file. Oh, I think I jumped the gun on that. Let me redo that here. System info. There we go. There we go. So we have our system info output here. And then what we're going to do is follow that up with WMIC. So WMIC, append, but what we're going to do is after the WMIC command, we're going to put pipe and more. So what we're going to do is we're going to take WMIC, so we're going to take any WMIC command. Right after the command, we're going to put a pipe. We're going to type more. And so what this does is it takes, and what more was a command that was slowing us down so we could read things a screen at a time. Well, more outputs in the ASCII format. So what we're doing is we're taking the encoding scheme that WMIC uses, and we're converting it using more to ASCII, and then we're going to redirect that to the file. So if I click this, I go back into SOFA. Now it's a lot more readable, right? Now we've got our output from WMIC, and you don't have a space in between every one of the characters. So if you're running any WMIC command, the WMIC command being QFE list, WMIC disk drive, or WMIC logical disk, you run in any of those and you want to store it to a file, then go after the command, put pipe more, and then redirect it to the file where you want it to go. And if you do that, then you'll have the output text will be in ASCII, and you won't get a screen that's just full of screwed up crap. So hopefully that makes sense to you guys. I know it's a bit, but I just, if you want it to be formatted correctly to be able to store it, then you kind of have to do this. I'll show you with PowerShell. It's a little bit different. You have to have a slightly different approach. So I got my PowerShell up. If I get local user, so we'll do that one. The way that you want to do this, so typically you could take and redirect this to the file, but PowerShell has a way in which you can explicitly tell it to use an ASCII format. So the way this works is after your PowerShell command, you're going to type out file. So it's going to be get local user pipe out file. You're going to put dash file path. I'll leave that up there a second so anybody who wants to catch up can. Right? Then you're going to put the directory where the file is. So in this case, you remember how we used %user profile to say, hey, this is the home directory? Well, in Linux, and so in PowerShell, you use, my program freaked out there. In Linux and in PowerShell, you use tilde. So right up in the upper left-hand corner, if you hit Shift and the little tick mark, you get a tilde. So that's, instead of using the user profile environment variable, you put that there, and it's the same thing. Then slash desktop slash the environment variable we talked about, env computer name.txt. So that's going to write it to the file that we already have there. At the end of that, you have to put append if you want to continue on with the file. If you don't, if you want the file to output something completely fresh, you can leave append out. But in this case, we're going to put in append because we want it on the bottom. And then the most important part here at the end, encoding is ASCII. So that means take this information that you are producing with this particular command, make it ASCII, and push it to this file. So that way we don't have this weird formatting. We're forcing it to be ASCII. So hit enter. It runs. I open up my file. Scroll all the way to the bottom, and there's my output. So we've got our administrator, default account, all that stuff. All my account information is down here at the bottom, and it's formatted correctly. Just to show you what it looks like if I don't format it correctly, if I get rid of this encoding here, close this out, run it again. Well, there we go. There it is. So we run it, go back. Yeah, and so this is what it looks like if you don't hit encoding ASCII. It just spreads it all over your screen, right? So you might want to just be careful and make sure that you format your PowerShell commands right. Just remember, take it, pipe it to out file, give it the file path, actually put the file path, and then append and encoding ASCII. So those are, I didn't want you to get into trying to redirect all these different commands to the file and it not work. If you find a new command and you're trying to figure out why isn't it formatted correctly when I send it to a file, this might be your problem. So figure out how to get that command to be ASCII output. If you can't figure that out. Now another thing too is if you take and you just run PowerShell and you just take PowerShell output and push it to a file, then you don't have to do this, right? Because all of your stuff will not be ASCII, and the file will format that correctly because it'll all be, I guess, what is it, UTF-16 or UTF-8. And so it'll all be the same. So the file format will be fine if you just run nothing but PowerShell commands. But if you start mixing between command line and PowerShell or command line and Wimic, that's when you run into problems. So let's see. I think we've covered that good. I'm going to show you kind of. Oh, we got a question. Yeah, does it say ASCII? It does say ASCII, Richard. Sorry about that. My fat head was covering the command there. Yeah, it does indeed say ASCII, ASCII, encoding ASCII. So sorry about that. I sometimes lose track where my fat head is. I'll try to move it down a little bit there. Yeah, so one of the things that we talked about, what I want to do on this podcast or in this live stream, is to talk about automating this. So this is let's see, I'm gonna have to get my fat head back up here. So this is a USB Rubber Ducky. It comes in a case that looks just like a USB drive. It even has the little piece here that fits over it. So yeah, looks like something you would get at a conference. But in reality, what it has a small SD card inside of it that holds a payload. This is billed as a pen testing tool. However, I think it works really good on the defensive side. If you open a browser window and you go to look for, I actually got it in the description of this video, it talks about Ducky script. So there's a link that'll take you and show you how you can write programs for the USB Rubber Ducky. Move this down. Very basic commands, like literally like from the programming language BASIC type stuff. I mean, right down to the first, if you want to just put a comment, you put REM. That's the same thing you put in BASIC. So so very simple to program in. We'll program something here. What you'll need is you'll need your Ducky, and you'll need the SD card for it, and then some way to convert your SD card and plug it into the machine. The way this works is we'll do a quick little demo program here. Is you're going to, one of the ways you can do this to encode, so there are several ways you can write the code. You can write it in Notepad. Another way you can do this is you can go to the Ducky encoder website and encode just write the actual code, I believe. Yeah, still loading, sorry. You can type the code straight into the website and generate your payload. Another thing you can do is on the Hack5 download website, they have an HTML file called JS encoder that looks like this. This one's my favorite to use because it will take an extreme amount of output. I have had the USB Rubber Ducky write megabytes of information to a computer before, and this particular Ducky encoder, the one that you can download put local on your box, handled everything. So I really like this one. But either one of them will work. So some basic commands that you might want to know is first is I always start off a Ducky script with a delay. So it's capitalized. You capitalize any Ducky script commands. So I always delay by 5 to 10 seconds. It's always in milliseconds. So it's going to be if it's in milliseconds, if you want 5 seconds, it's going to be 5,000 milliseconds. So delay for 5,000. At that point, what I'll do is type in, let's say, string, right? So this is just a starting, just to kind of show you how this works. If you type in string, what that says is type in anything that comes after the string command. So I'm going to type in, this is a test of the Rubber Ducky. All right. And I'm just going to give it a little bit longer to delay, just because I'm just plugging this in. So I've got my delay, I've got my string command, and let's just say that's it. So that's all I want my ducky to do. I can type generate payload. I'm going to download that payload at that point. And you can do that here as well if you wanted to. So if I took and went to the Ducky encoder on the website, I could paste that in, generate payload, download the payload. It's going to do the same thing. It's going to give me the payload. So what happens is you need to take that micro SD card that you get out of the Ducky, or that you're going to use in the Ducky. You stick that in your computer, and what's going to pop up is this file. The SD card will pop up, and usually there'll be an inject.bin file already in it. If there's not, it doesn't matter, but you're going to erase it anyway. So we're going to erase the one that's there. I'm going to take the one that I just made, and I'm going to copy it and paste it into the SD card. You have to call the file inject.bin though. So you'll write these over and over again, but it has to be called inject.bin. Then you want to safely eject that file, or safely eject the SD card. I'll pull this out. I'm going to put it in my rubber ducky. And then I'm going to bring up a notepad so that when it starts to auto type, it just doesn't type random stuff all over my computer. So now I'm going to take the rubber ducky with the SD card inserted, and in 5 to 8, well, 8 seconds, it's counting down now, it's just going to type the payload that we have for it. So give it some time. There we go. So that was all auto-typed from the Ducky itself. So it says this is Rubber Ducky. So you can see kind of the power of this, right? We can take this and then write some code using different commands of the Ducky script to get things done. So I'll get you started on this. And show you sort of the way to do this. And I think what I'm going to do, because we've been going for 2 hours, I didn't expect to go this long. I always prepare more material than I have. Is we're going to have another live stream, and let's do the next live stream. Actually, while I talk about this, go ahead and put in your comments when you'd like the next live stream. If you'd like it to be done next week, next Tuesday, so you have a live stream per week, that's cool. Or if you want it sooner, right? If you want this to be fresher in your head and you want to do it, let's say Friday. So, those are the two, kind of the two choices, Tuesday or Friday, right? Or if there's another day that works that's better, let me know, explain why. And it's going to, sorry, just read a comment here. Yeah, if there's a day that's better, let me know that. So Mr. Shea just said the delay allows time for operating system to enumerate the device. That's true. So the reason the delay is there is so that sometimes, like for the rubber ducky, when I just plugged it in, it knew right away just because I plugged this rubber ducky in this machine 1,000 times. But it does need to load drivers sometimes if you put a new rubber ducky in the machine. And so that delay is for that to happen, for Windows to load drivers, for it to recognize it. You always want that. The other reason it's there is in case I screw up bad. So in other words, let's say I realize as I'm plugging this in, like, holy smokes, like I just asked it to delete stuff I didn't want to delete. Well, if I didn't put that delay in there, then it might start right away, right? The other thing to realize, we're going to be looking at something called the Teensy. So it's a small microcontroller that does the same thing as the Ducky, but does it cheaper, faster, and it's more flexible. So so that Teensy there, sometimes you can convince the computer so hard that it's a keyboard that you actually have to physically do something on the Teensy in order to get the code to upload to it. And if you don't have a delay there and you put it in the machine, it just starts right away, then it might get kind of difficult to program your code. So I'm starting to see some Tuesdays rolling in. Cool. So we'll do that. We will say next Tuesday at 10, we'll do this again. And here's what I want you to do between now and then. There's a website. So if you go to, if you type into Google, just type in Teensy. It's going to come up with the Teensy USB development board. So it's pjrc.com/Teensy. If you want to get involved with kind of the programming of these things for next week, Teensy 4.0 is the one that you want. It is an absolute monster of a microcontroller. You can see there for the processing power, just the previous version of the Teensy, and now what this thing has on it. It runs an ARM Cortex M7, 600 megahertz. There's a 600 megahertz processor on this thing. That hurts me. It's like my first computer was worlds behind. This thing has just the brains that it's amazingly fast. But it's $20, right? A rubber ducky. I don't know what the going rate is right now. I think it's like $50. Yeah, it's like $50. And you can pay $20 for this Teensy and get more capability. And it's a little bit more difficult to use. I will say that the rubber ducky is super simple to use. But the Teensy has a lot of power. It's faster. It's a lot more flexible. And what we'll do is the next live stream is I'll go over how to program the Teensy. And so if you order from them today or tomorrow, it will get here pretty fast. I ordered mine on Thursday and they were here Monday. And so I actually ordered these thinking like, oh, it'll be fun. If they get here, it's fine. I was just going to use my older Teensy that I acquired at a class. That's a Teensy 2.0 that'll do the job just fine. I was going to use that for this, but they got here so fast, I was blown away. So yeah, if you order those today, you will probably have them in time for next Tuesday if you're in the United States. If you're not in the U.S., don't know. But we'll definitely, next time we'll go over the Ducky and how to program commands up for that. And we'll also go over the Teensy. And if you want to give the Ducky a try, if you have a Ducky at home, feel free to try that out. And if you want to buy a rubber ducky from Hack5 and support them, great team. Also, if you have any questions over what we went over today, go ahead and put it in the comments. But great guys out at Hack5. The guy that owns the company used to work in Northern Virginia, kind of in that area, doing a bunch of stuff, doing some sysadmin stuff, and developed this because people kept asking him to do stuff over and over again. So like, hey, my printer died, or hey, like I need to put this thing on the network, or hey, this is busted. And he found out that he was just doing a lot of repetitive tasks over and over. So he made this thing, and he made keychains and put them in the closets along the corridor. And if somebody called up and said, hey, I need my printer loaded, he'd just go to the closet, grab the one that says printer and plug it in your machine, and it would just auto load the printer, right? So this it's a great. It started as just an admin automation tool, and now it's a pen test tool. But they've got a lot of support. The forums that they have for this equipment of theirs, they've got some strong support there, and got some just some good people running the company. So if you want to grab that before next week, I'm not certain how soon that can get to you, but or if they're even shipping right now, you might want to look that up because of the whole virus thing. But I know that that the Teensy people are shipping, and apparently shipping fast. I think they must be pretty hungry. So Jeff says, can you post the specs for the Teensy and if we need any USB adapters? Yeah, so the spec for the Teensy, if you go to, I'm going to throw this in the comments. So I keep forgetting I have the comment thing there where I can throw this in there. If you go to the link I just put in the comments, it will give you the specs on the Teensy, on the 4.0. The 4.0 is just absolutely blazing fast. I've used 3.2s a good bit, a ton. And the 4.0 is just like, I don't even want to say it types fast. It types instantaneously. It's ridiculous. But the thing is it's also a microcontroller with a very fast processor, so it can do a lot more than just type fast. It's amazing. And the great thing is whether you get the 4.0 or the 3.2, which is the model down, the 4.0 is actually like cheaper by 15 cents, right? So you just go ahead and get the 4.0 and be done with it. And USB adapters. Yeah, so what you will need is just make sure you have a cable that will go from micro USB to your normal USB, and you'll be fine. I have used the adapters that the OTG adapter you just slide into micro. It's a direct thing that goes from micro USB to full USB. But if you have a micro USB cable that you've used to charge a phone for a while, that's all you'll need as far as being able to plug it into your machine. Also, make sure that in the description of this video and on the SkinnyRD website, you will find resources. So if you're going to be using the Rubber Ducky, the resources there for the encoders. If you're going to be using the Teensy, you need to download the Arduino IDE, which is there in the description. You need to download the Teensy Duino software, which is also in the description. And there was one other thing. There is a library that we're going to be using. It's spelled PHUKDLIB, Fukt lib, we'll call it. You're going to want to download that library, and if you don't know how to use those files or whatever, I'll go over next week how to put those files in the Arduino library so you can access it. So cool. So don't see any more questions over there, guys. Thank you for showing up. Looks like we've had consistently throughout the entire live stream a good 50 to 55 people, very involved. If you know people who would like this content, like I said, next week we'll just be exclusively focusing on whatever your questions are and programming the Ducky and the Teensy and how to do that. Tell your friends, tell people who would appreciate the content. Also, if you will put in the comments, I'll just leave the comments up for a while, leave the stream up so you can put some comments there. Other things you might be interested in for live stream. I have a list here of things. So this defensive commands thing was one thing. So next week will be auto typing. I have KiCad down, so that's a software that you can use to build your own circuit boards. So if you're interested in that, let me know. We can do a live stream on how to build a circuit in KiCad, and then I can give you information on how you can order the circuit board online, and it just comes to your house. Basics of building a circuit. My wife told me I've got a kind of an overhead camera that can look down, and I can show you how to use a breadboard and stuff if that's of interest. If it is, let me know, and I can get you kind of a small buy list of probably 20 to 30 bucks worth of parts that you need to buy in order to go through that. We can combine those to where we build a circuit on a breadboard, and then we actually use KiCad to make a professional looking circuit board, and you can get that in. If that's something that you want to do, just let me know other ideas that you might have or things or questions, and we'll try to make a live stream out of it. So cool. Thanks for coming, and I'm going to mute me now and just leave the stream up for another 5 to 10 minutes so you guys can talk with each other or chat, and I'll be in the comments. So thanks a lot for coming, guys.